So the purpose of all this analysis and generating a model is to be able to use that model to either predict something in the future or predict something beyond your data set, or to model something that lies within your data set to get some average or expected values. So that activity is it's called interpolation if you are sampling from within your data set, or extrapolation if you are going beyond the set into places where you aren't able to sample. So as an example of that, perhaps you remember the grades versus hours of studying example from the last section, where we generated this particular line with this particular and not very good correlation coefficient, which made this particular line on this particular data set. So if I were to give you an example of interpolation, you might ask yourself, what grade should I expect to get if I study for 8 hours? So this is an interpolation because 8 hours is within the range of your data set. So those numbers you can see go from as low as 2 hours all the way up to 12 hours. So I've asked for an x value that sits inside that range. Well, the answer to this, what grade should I expect to get if I study for 8 hours, I just need to take my 8 and plunk it into the x value for my model and then calculate away. So y equals 1.289. There's my 8 plus 68.074. So if I fetch the calculator then, .289 times 8 plus 68.074, I get 78.386. All right. So the answer to this question, what grade should I expect to get if I study for 8 hours, is the model predicts that I will earn 78.386%. Well, it's not a complicated calculation. You just take your x value, drop it into the model, and see what you get. What's a little more complicated and requires a little bit of intuition is, how reliable is this? How much do you trust this value? And when someone asks you that, as they should, and anyone engaged in critical thinking should always question facts that they're presented with, I say, you'll get 78.386. And you say, well, how sure are you? And I say, well, based on the correlation coefficient of 0.497, I'm not real confident that this model will result in that number, but this is the number the model, based on the data, spits out. So as far as my data shows, this is the number you could expect to get as your final grade. But keep in mind, the correlation was fairly weak. So we'll try another one. This was the first type of interpolation where I provided you the number of hours studied. The other one is to ask how many hours I'd have to study to get a certain grade. So if I clean that off for a minute. So, new question. How many hours would I have to study in order to earn Now, I'm going to put a number here in a minute. I'm just going to pick a grade. In order to keep it an interpolation, though, I have to keep something from within the range of my data. So I think the highest mark in that data set was a 90, and the lowest mark in that data set was a 60. So I'm going to pick something in between there, nice and round. I'm going to go with 80%. All right, so again, it is not a very complicated calculation. You start with your model. But this time, I've been provided a grade, which is the y values, not the x's. So my 80 goes here. I'm going to have to do a little bit of algebra. To get this x by itself, I'll have to kick that to the other side. And if I grab my calculator for that, 80 minus 68.074 gives me 11.926. And to break this multiplication, I need to divide both sides. So 11.926 divided by 1.289 should give me the number of hours I need to study. So if I do that, divided by 1.289, I end up with 9.252. So according to this linear model that we calculated based on some data, in order to earn an 80%, I should expect to study 9.252 hours. Now again, the question comes up, how confident am I in that result? And based on the same factors as before, this correlation coefficient of 0.497, I'm not very confident at all. In fact, this number 80 happened to show up 3 times at 3 different values of hours studied. So you can maybe see how this correlation coefficient is related to that fact, that this is so poor because this number showed up at so many different places. All right. To do an extrapolation, I need to try and use this model to predict a value that would lie outside of my data set. So instead of asking about a time that's within 12, I'm going to say, what would my mark be? If I studied for so let's pick one that's just outside. Our biggest number of hours studying was 12. Well, I'm going to go with 15. 15 hours. So it doesn't matter that it's an extrapolation. It hasn't changed how you do the calculation at all. It just changes where those data points fall relative to your set. So I go back to my model. And 15 hours. Hours is an x value, so it's going to go here. And I'm going to have to do some calculating here. So 1.289 multiplied by 15 plus 68.074 gives me 87.409. So according to this model, if I study for 15 hours, then my mark should be 87%. Well, that's all right, but there's a danger with extrapolations. If you go too far, you're not only using a line that's maybe not trustworthy in the first place, but if you go too far beyond your x values or your y values, then you're testing things that aren't meaningful. I try and think of an example. If you were to eat Timbits and measure how much that increased your happiness, then one assumes the more Timbits you eat, the happier you get. And somebody who's eaten 10 Timbits might be happier than someone who ate 2, and someone who ate 15 Timbits might be happier than someone who ate 10. But I promise you that someone who ate 10,000 Timbits is not going to be happier than those people. And that's because you've taken this model, this assumption that more Timbits means happier people, and you've tested it past the point where it makes any sense, where a new mechanism takes over, and the just general discomfort from having eaten 10,000 Timbits sort of dampens your mood a bit. So the way I'm going to check to see if I've gone too far is to see if this x is an outlier compared to my set, or if this y is an outlier compared to my set. So for standard deviation, we've been using 3 jumps of standard deviation in order to define an outlier. So for the x's, 6.667, which was our mean, plus 3 of these standard deviation jumps ends up giving me heartburn. It's giving me heartburn because I can't enter these numbers properly. 17.575. Alright, so this 15 that we picked sort of out of the air is less than 17.575. So this x value is not an outlier for this particular set. So this was a safe extrapolation on a bad model. So when someone asks you if you're confident in this result, that's your answer. It's a safe extrapolation, but the model is not that reliable. So trust it if you at your own risk. Just to be thorough, if you check the x, you should check the y. So our average y was 76.667 plus 3 of these jumps is 76.667 plus 3 times 9.428 is 104.951. So as long as I keep under 104.9%, then I haven't given myself a bad extrapolation. So this answer here, 87, is under that number. So it's within the safe range in the x sense, and it's within the safe range in the y sense. The only question you might have for this particular extrapolation is how strong the model is. So as the last example on this particular data set, how many hours of studying would you have to do in order to score 40%? So again, we go back to the model, as always. And I can tell this is an extrapolation because 40% is lower than any other mark in my data set. So I am going outside the range of the set for this one. Doesn't change your calculation. I've just got to plunk the numbers in. 40 is a y value, so it goes in over here. And we have to do a little algebra. Subtract this from both sides. perhaps you see the problem with where this is going. So according to this model, in order for you to get 40%, you would have to study negative 21.78 hours. So while this is a silly example, it is underscoring the danger of extrapolation. First off, what does negative studying look like? Can you unstudy? Can you study backwards? Are you doing this in the past instead of in the future? I don't know how to interpret this number. So already, before we do any thinking about it, this answer doesn't make any sense. And part of the problem is that you extrapolated too far. So you took this beyond the data set into a place where the numbers don't make sense anymore. In order to confirm that, we can check with some standard deviations and see if this value of x would be an outlier. So if I were to take my average x, or average y, sorry, which was 76.667, and subtract 3 of those standard deviations, I end up with 48.383. Now this number is below that. So you've picked a y value that is beyond outliers for this particular data set. And part of the reason that this didn't work is because that happened. So if somebody were to ask you this question, well, how much studying would I have to do to earn a 40%? Not only have you put this number into a model that is already not reliable, but you've put in a y value that is well beyond the range of the data that you used to build the model in the first place. So you shouldn't be surprised that you get a crazy result. This is poor management of statistics. You have to be very careful when extrapolating and make sure that you don't end up choosing x's and y's that are outliers. So if you're ever asked a question to extrapolate or interpolate something, I need you to be checking this to make sure that you haven't stepped outside. And someday, when someone is paying you $100,000 a year in order to collect data and project sales, then you should be certain that you are not stepping outside of outlier territory when you're doing your extrapolations. Otherwise, you are charting a course for disaster. If we were doing some extrapolations on this particular data set, which you may also remember from the last video, we're going to ask, what does 14 hours of reality TV do to my IQ? So in this data set, I had hours of TV on the x-axis and the IQ values on the y-axis. So that's IQ versus hours of reality TV. So I did generate a model, which was here. So if I've been handed a number of reality TV hours, that's an x value. So I'm going to drop that in my model. 6.022 times 14, because that's the hours I'm checking, plus 129.746. Is 45.438. So according to this model, 14 hours of reality TV will have lowered your IQ to 45.438, which is about here. And you can see that showing up on the model nicely where that line crosses the 14-hour mark. If if I can actually hit the 14-hour mark right in there. Is that a safe extrapolation? Well, in order to go up to 14, I'd have to go up from my x average. So let's check that. The average x was 6.6. And if I take 3 steps of the standard deviation, I end up with 17.265. So as long as I don't check any x value bigger than that, I'm in the zone for a safe extrapolation. And based on this correlation coefficient, if this data were actually taken from an actual study, then everybody who has ever watched reality TV should really be terrified, because this number is saying if you watch reality TV, your brain will rot. Now, I just made it up for fun, obviously, but you can see the point, hopefully. So this was a safe extrapolation because 14 is not an outlier, would not be considered an outlier in this data set. If I were to ask a sort of crazier question, when does my IQ hit 0? So this is the other type of interpolation, extrapolation. I'm providing you a y value now instead of an x. So when does my IQ actually hit 0, and I'm rendered as clever as a, say, potato, although you might argue potatoes have some capacity for thought. I mean, they do grow and kill bugs and stuff. So anyway, if I were to put this in for my y value, 0, negative 6.022 x, the irony of a question about IQ and I can't draw my x's properly, plus 129.746. Pop this over. Divide both sides. We get 21.5. So, according to this model, again, gathered from very rigorously collected and tested data, if you were to watch 21.5 hours of reality television a day, your IQ would finally drop to 0. Now, the model is strong. The correlation coefficient here is highly linear. So this line is saying that that might be true, but a critical thinker would look at this number here and say that 21.5 is outside of where your outliers sit for this particular analysis. So while the model is strong, it is unwise to be making any claims for any x value that is bigger than this. So 21.5 is more than this this particular outlier boundary. So I would say I couldn't trust this result because it's been extrapolated too far, regardless of how strong the model is. Just to be thorough, I'm going to check the y. The average y was 90. And I need to drop 3 standard deviations to try and get to 0. So 90 minus 3 times 21.9 gives me 24.3. So that shouldn't surprise you that checking any IQ level lower than 24.3 is outside of the outlier bounds for this particular data set. So again, despite the fact that the model was strong based on this correlation coefficient, I have extrapolated too far, well beyond the lower bound of 24.3, which this data set allows.